So we're going to be doing redox reactions or oxidation and reduction. So in a redox reaction, you have one atom and then you have another atom. And basically what this is a transfer of an electron from one atom to the other. In a way, this one is losing an electron and this one is gaining an electron. And that process, they both have a specific name to call that process. And when it's losing an electron, it's called oxidation. And when it's gaining an electron, it's called reduction. And then a way I remember this is oil rig. And that is oxidation is loss and reduction is gain. For me, that was kind of hard to remember that reduction is gain, because I think of reducing as in you get reduced, so stuff gets taken away from you. But when you're gaining an electron is a negatively charged particle. So let's say you're a +3 charge, and then if you have a reduction to you, and that's you gaining an electron, well, if you gain one electron, that's one negative charge, so you go from +3 to just +2. And then if you gain another electron, you go from +2 to just +1. And then if you gain another electron, you go from +1 to a neutral. And then if you gain another electron, you go from neutral to -1 charge. So when you're gaining an electron, your charge is being reduced negatively, and so that's another way how you can think of it. Now, let's say we have a reaction going, and it's you have Na and chlorine. And just elements by themselves, they have a neutral charge. But when they come together, these two, Na actually gets a positive charge, slightly positive, and chlorine gets a slightly negative charge. And there's a reason to this. That's because Na gave an electron to chlorine. So this one is being oxidized and this one has a reduction. And so this becomes slightly positive and this one becomes slightly negative. And so when you have two atoms that are slightly positive and slightly negative, when they come together, they actually will cancel each other out because nature does not like charge. So then this together becomes a neutral charge. But when it gave its electron, Na became slightly positive and chlorine became slightly negative. And so we can call this one oxidation. And this one is reduction. Now, something we can write from this is called the half reaction. So when we write the half reaction equations, for sodium that's being oxidized, you can't have any minus signs. So you have to write it like this. You have to write it Na positive plus an electron. And when you write it on this side, it's saying that it is losing an electron. But with chlorine, you can actually put it on this side and it shows that it is gaining an electron. All right, so let's go back to the atom A, atom B, and how atom A gave away an electron to atom B. Now with oil rig, this atom right here is being oxidized. And this one is being reduced. So this one's going to be slightly positive, and this one will be slightly negative. Now, since atom A is able to give an electron up, it is going to be the reducing agent. And since atom B is able to accept an electron, it's going to be the oxidizing agent. In every chemical reaction, you're going to have an reducing agent and you're going to have an oxidizing agent. And when you have a redox reaction, you're always going to have an oxidizing and a reduction. It's always, it's a transfer of electrons. You're not going to have more electrons than when you started, and you're not going to have less electrons than when you started. So, if we look at H2O, we know as a whole, this is neutral. We also know H and O, elemental form, it's also neutral. But when they come together, some electrons are exchanged, and we can find this out by looking at the periodic table. Now, for hydrogen to become a noble gas, it's going to want to lose an electron. And so it's going to become slightly more positive since it lost an electron. So since it just has to lose one, it's just going to be a +1. Hydrogen will be a +1. And since oxygen is going to have to want to gain 2 electrons to become a noble gas, it's going to be -2 because it has to gain 2 electrons. Now, if we write that together like this, hydrogen and just oxygen, that's going to be +1, and this is going to be -2. Now, as a whole, that comes out to be -1, and nature doesn't like charge. So, the way to get this to 0, you would want to give another hydrogen in there, since it's a +1. So that's why it's H2O. This is a +1 charge, but there's 2 hydrogens, so that becomes a +2. And since there's 1 oxygen, it's going to be -2. And as a whole, this comes to be neutral. Another one we can look at is calcium and chlorine. Now, these come together, make C like that. Calcium, as we can tell right here, 1, 2. It's going to give up 2 electrons. So that's going to make it a +2. +2, +2. Now chlorine is going to accept 1 electron to become a noble gas, so it's going to be -1. -1, -1. Now together, right here, this gets a +1. That's not supposed to happen. So what can we do to balance this? Well, if it's +1, we need another negative in there, so that cancels out that positive and makes it neutral. Well, if we just add a 2 right here, that means there's going to be 1, 2 chlorines. Well, that's going to be -1 and -1, and so together that makes -2. Well, if that makes that -2, then that's -2 over here, and we have to write this 2. So +2 and -2, this becomes neutral. That's how we want. So when we want to balance an equation like that, you want to make sure everything, like every compound and everything like that, it's neutral. You don't want to have a charge to it. So another one we can write is Now, if we look at this, we know hydrogen, that's going to be a +1, right? And then oxygen, that's going to be a -2. And since there's 3, it's overall, it's going to be a -6. Okay? Now, if we have a +1 and a -6, this right here has to be neutral. So we have to have a +5. Because 1 + 5 and then -6, all that together, that's going to be 0. Now we know H, that's +1, but with 2 of them, it's going to be +2. So then the S has to be -2 so that it could be neutral. Now S by itself is going to be neutral. All elements are neutral by themselves. And so we know oxygen is -2. That means nitrogen has to be +2 to keep this neutral. And then we already know what H2O is. Now, if we look at this, I'll rewrite this. Now, when we look at this, we know oil rig, and we know that the thing that's going through oxidation is going to be the reducing agent. And vice versa. So when we look at this, nitrogen goes from a +5 to a +2. It's being reduced in this number, so that means it's going to be the oxidizing agent, the oxidizing agent. And then we also can see S. It goes from -2 to just a neutral. So it loses 2. So this is going to be the reducing agent. And we can see all that through the difference in the charges from the left side to the right side. And we could tell all those charges by looking at the periodic table and seeing where it goes to become a noble gas, because everything wants to be a noble gas. So fluorine, it has to gain an electron, so it's going to be a -1. And then oxygen we know is -2, and nitrogen's -3, and hydrogen is +1. Calcium's going to be +2, and so on and so forth.